morning children. We are proceeding to Chapter 8, Sampling Techniques and Statistical Inference. Sampling. All of us are familiar with this word sampling. You go to a shop. If you are going to buy rice, do you just buy it? No. Before that, we take a handful of rice and we check it. Check whether it is of good quality. This handful of rice is of good quality. We assume the entire sack is good. Similarly, if I want to analyze the performance of a particular set of children, the set may contain even 80 children. If I want to inspect them, I need not check each and every one in that set. Rather, I select a set of 5 children or a set of 10 children, analyze their performance, their notebooks, their record work, and how much they answer, their marks in the exam. With that, I can generalize the performance of the entire set. So 5 or 10 children represent the group which I want to inspect about. So these things we come across in normal day-to-day life. Supposing a manufacturer wants to check the condition of his production, say cars, he need not inspect each and every one. There may be a lack of production, but if he inspects around 15 or around 20 at random, if this set what is selected is good, it comprises of all the conditions, then he can easily say the entire production is good. There may be a good reputation for that particular concern. So this chapter we are going to learn about various techniques involved in sampling. Let us be familiar with certain words. The very first thing, what do you mean by sampling? To put it in proper words, we can say sampling is a process of drawing a sample from the population. Sampling is a process of drawing a sample from the population. It's just a process of selecting the sample. Now we are learning two words, sample, population. What is population? The example that I gave you. The sack of rice is the population. The handful that I check is called sample. The entire class is the population. The students whom I selected, 10 children, 5 children, that is a sample. The production in a lakh, that many cars is the population, and what he selected, say 10 cars, 50 cars, 100 cars, this is called a sample. So from this word, we will understand population doesn't exactly mean people. Population is the group of items under study. It may be cars, it may be people, it may be students, it may be any production I can say. So population is a group of individuals under study. Instead of people, it can be things also. The next idea, sample. From the population, we select a group. This group should represent the population. So a representative subset of the population we called a sample. The sample, how many I select? 5. Then sample size is 5. If I select 10, sample size is 10. So sample size tells me number of individuals in the sample. The very next idea, population is a big thing. Sample is a small thing. Both we can find out some statistical constants. So since we are in the chapter statistics, naturally we are interested. What is the mean, median, mode, variance? Like that. Many statistical measures are there. Finding statistical measures for a population. That statistical measures I call parameter. Population starts with P. Remember, parameter starts with P. So, population constants we call parameter. Same way, I can find constants for sample also. So, the statistical measure computed from the sample that we call statistic. So, parameter the examples. Mean we can denote mu, variance we can denote sigma squared. Whereas statistic, from the sample I find out the mean, that is called x bar. From the sample I find out the variance, that is called s squared. So these are the very basic terms before we learn the methods of sampling. Types of sampling. What are the types of sampling? We have two types, non-random sampling and random sampling. In this section, we are going to learn about random sampling. Random sampling, there are many methods. We are discussing about three different types of sampling. Simple random sampling, stratified random sampling, and systematic random sampling. What does the word simple random sampling mean? Simple. The procedure is a very simple one. Every individual under this population has an equal chance of being included in the sample. Every individual in this population has an equal chance of being included in the sample, and that is the major idea of simple random sampling. We are going to discuss in two different methods. Number one, lottery method. Number two, random number tables. What is this lottery method? For example, there are 50 students in front of me. Let me take the 50 students as my population whom I want to analyze. I want to get a sample of only 10 children from the 50. 50 in front of me, but I want only a sample of 10. How am I going to do about? Take 50 slips of equal size, color, shape. All the 50 slips should be identical. Write number 1 to 50 because 50 are there in front. Write 1 to 50. Each slip is having one number. Put all the slips in a box. Shuffle it properly. Now all the slips are mixed. Select one by one. I want 10. Select 10 slips. That slip is having whatever number, include that. Suppose 8 is coming, the child numbered 8 is included. Suppose 50 is coming, the child numbered 50 is included. So, there are 50 in front of me whose numbers I have put in the box, shuffled properly. From the well shuffled box, I am going to select 10 slips if I want a sample of 10. So, this is called lottery method. Now, before I select, every child will think my name or my number would come. So, everybody has an equal chance of being included in the sample. So, this method we call lottery method. So, capital N we say the size of the population, small n we say the size of the sample. So, from capital N, select small n just by writing n slips. Select only small n slips. So, this method we call lottery method. Now, the question is, if there are 50 in front of me, I can easily write 50 numbers, put it in a box, shuffle, all that. Suppose 5 lakhs are in front of me. Is it possible for me to write all the 5 lakh numbers? No. It's a cumbersome procedure. So, what should I do? In that case, we have another option, say random number tables. The table of random numbers are designed by many people. We are following Tippett's random number table. In this table, 0 to 9. These are the only digits we have in maths. So 0 to 9 are mixed and matched. So this will be repeated in equal number of times in every row, in every column, in every diagonal also. So if I want a 2-digit number, I can start from a row, combine 2, 2 and I can select it. Or I can start from a column, combine 2, 2 and then I can select it. If I want a 3-digit number, take 3 digits and select it. I can go row wise, I can go column wise, I can also go diagonally. I can start from 5th row, 15th row, 25th row according to my own interest. Not that I need to start from the first row. So in a page of the random numbers table, the full page contains a combination of digits from 0 to 9 in a manner that every digit is coming equally. So 0 is coming 100 times in that page, 1 also will come 100 times in that page, 2 also will come 100 times. So every digit is equally repeated in a particular page. Select any page on your own. Select any row or any column or any diagonal. Start combining. I want 3-digit number, combine 3, 3 and select. I want 2-digit number, combine 2, 2 and then you can select. So this table we will refer to in the exercise and we will understand it in a more vivid way. Now we are seeing what are the merits and demerits of simple random sampling. As I said, writing the slips or selecting from a table, I cannot choose exactly roll number 10. I cannot exactly pinpoint some number in the table. So, human bias is not at all there. When I put the slips in a box and I select, nobody knows which number will come. So, human bias is completely eliminated. So, personal bias is not there. I cannot purposely select someone. So, that I cannot do. Number 2, it's an easy procedure. So, in all economics, commerce questions, our usual way of writing, this particular method saves time, cost, labor. So, the same idea we have said, simple random sampling saves money, time, labor. So, these are the merits which we can highlight. There are some more also. At least we must be able to say 2 in each case. Demerits. Every system will definitely have demerits also. Here, what is the case? Only if I know all the 50 in the set, then only I can write and put it in a box. Only if I know the complete list of what I am going to do, I can use this procedure. So this procedure requires the complete list or up-to-date list or current. Okay, so that is not available in certain cases. So in that case, this method cannot be applied. Number 2, there are 5 lakh units. I am selecting only 50 from that. When the sample is very, very small, it may not represent the population. So if the sample size is fixed to be very small, it does not represent the population. So these are the demerits. The next method, stratified random sampling. What do you mean by this word, stratified random sampling? Stratified, that is, divide the population into strata. Why should I do that? Suppose around 10 or 15 families are gathering for a party. I want to give them some questions. In that questions, some may be known to teenage people. Some may be known to children, kids. Some may be known only to the adults. So when I want to divide them into groups, it is better. Let me collect all the adults together. Let me collect all the teenagers together. Let me collect all the children together and grandparents, very old people together. Each group when I want, put some from parents, some from grandparents, some from teenagers and some from children. So each group will have all the combination. What I put into the different age groups, I call strata. From each strata, I select a few and that will represent a sample. So this is called stratified random sampling. If I don't do this, if they are of various age groups, I cannot simply put there are 50 in front, I want 10. No, I can do it only when the population is identical. All are age group 15. I can do simple random sampling. But when age groups are different, when production levels are different, when the ideas are different, we definitely need to classify them according to age or according to levels or according to production or according to efficiency. We need to classify them. So classify them into different groups is called strata. That different groups we call strata. So divide into strata the entire population. From each strata, select some for the sample. So this is called stratified random sampling. What are the merits in this? We can definitely say, if I classify and select, it will represent the population in a very nice way. So it is more representative of the population. Number 2. Even if I select a very small sample, even if the size is kept small, without losing accuracy, I can select the sample. So these are the merits. Because I am dividing into strata, it is easy to administer also. So these are the merits. What are the demerits? As I listed out what all I must do, it is a big procedure. So the very important thing I will say, it needs a lot of money, time and experienced people should do that work. So this sampling requires a lot of money, time and experience. Then effect of bias, definitely, because I'm going to divide into strata and I am going to select. So I can select some people whom I want. So human bias is there. So personal bias slightly will be there in this method of sampling. The next idea, suppose I classify wrongly. Due to faulty classification, the variability will come. From sample to population, variation will definitely be there if it is classified in a fault manner. So these are the demerits we have, and there are merits also. Depending on which population we are doing and which nature of work we are doing, let us select the type of sampling. We have one more type, say systematic sampling. The word systematic tells the procedure is a systematic way. Suppose there are 5,000 persons in front of me. This is my population. Population contains 5,000 from whom I want only a sample of 500 individuals. From 5,000, I want 500. How shall I do it? Every 10th person, if I select, naturally, I will be able to select the 500 immediately. I need not write in slips. I need not put in a box. I need not shuffle. I can simply say the word. 5,000 are there. 500 I want. From 5,000, how to select 500? An easy way of mathematics. 5,000 by 500, which gives me 10. So every 10th person is included in the sample. Now, first person alone we have to select. First person, if I select 2, then 2 plus 10, 12th person, 12 plus 10, 22nd person, 22 plus 10, 32nd person, and so on. I can keep on selecting and they will create the sample. So this method we call systematic random sampling. I can say it is a commonly used technique of sampling. The complete list is required. 5,000 are there. I need all the 5,000. Then only I can select every 10th person. Or if I want only 100, every 50th person I can select. So to do that, I must know the entire list. Then only I can proceed. Before selecting every 10th, every 50th like that, arrange it in an order. Either numerically or alphabetically, or if it is land, position, all that is there, arrange it geographically. So in any of the orders, arrange it. Select the first unit at random. As I said, select number 2, select number 7, select number 10. So first one we need to select. Once we select the first sample unit at random, the remaining units are automatically selected. How do we select it automatically? What I told you, every 10th term or every 50th person, that every what, that is called K, where K we call sampling interval. That interval, how do we find it? Capital N by small n. Capital N stands for the size of the population and small n stands for the size of the sample. So divide the population size by sample size, I get an integer K. So every kth item is selected. So suppose K value is 10. Every 10th item is selected. Suppose K value is 20. Every 20th person is included in the sample. What are the merits? So whenever we decide some sampling technique, immediately we must know what are the merits, where it is suitable, all that. So what are the merits? Just by the name, we didn't work hard. We have to know how many are there, how many we want. We just calculate mathematically and we easily do the work. So it is the most simple and convenient sampling. Number 2, we do not use much of a time or labor. So time and work definitely reduced in this method of sampling. Number 3, it is evenly distributing. See, when there are 5,000 persons and I want only 100 persons, who all I am selecting? 5,000 by 100, which will be 15. So every 50th person is included. Suppose my first number is 7, then 57, then 107, then 157. Like this I will go till the last number, say 4,957. So the numbers or the persons right from the first till 5,000 we are including. So even distribution also, the entire list is involved in the sample. So this distributes the sample more evenly over the entire population. What are the demerits? Very first one, only if the complete list is available, we can do this work. So that is one thing. Second, they are not random samples. Every this term I am selecting. The next one, if K is not an integer, when I divide capital N by small n, if it is an integer, it is well and good. Otherwise, if it is a fraction, selecting samples, there will be some bias. So, K is not an integer, the sample selection will be little difficult. So, these are the demerits in systematic random sampling. Sample is a representative of the population, but we may commit mistakes while selecting a sample, processing or analyzing. So this particular section we are going to learn about errors in sampling. What are the errors? The errors may be sampling error or non-sampling error. What is sampling error? This error arises in the normal course of investigation or the enumeration. So this especially we can say they are chance errors. Just like that it may happen. What all may be the reasons for it? The very first one, faulty selection. The unit that we selected itself may be wrong. So a faulty selection is one of the reasons for sampling error. Number 2, I put one person in and I analyze. my analysis is not helping me in a better way. So what I do, put this person out and a convenient one I am substituting. If I use number 42, it is not easy for me. But if I use number 45, it will be easy for me. So like this, if I put one number out and select some other number, if I put some persons out and select somebody else, these things also will give rise to some errors. So substituting a convenient sample is another way for sampling errors. Number 3, while we are surveying areas, the border lines we have, we may make mistake in marking the border line. So that we call faulty demarcation. So faulty demarcation is also a reason for sampling errors. Second one, non-sampling errors. Non-sampling errors mainly arise due to human factors. We may make mistake while selecting, while estimating, or while measuring. The person who is doing neglects the work or his carelessness may lead to non-sampling errors. Not only the one who is investigating, the one who is responding. For example, we prepare a questionnaire. We want to know something about a brand, say a toothpaste. So when people give you some questionnaire, it will have some 20 questions. I may be lazy to write it all, or I may not be willing to write it all, or I may not have time to write it all. So some questions just like that I may answer. Some questions I need not answer, I will just leave it. So incomplete questionnaire, it's not the problem of respondents. So the problem may arise the one who is creating the questionnaire or the one who is answering also. So negligence and carelessness in both the parts will lead to non-sampling errors. The second idea, the investigator, if less qualified, he might not be efficient to do the work properly. So naturally, he will commit mistakes. The next idea, the questionnaire itself can be wrong. It may not suit the very idea of my analysis. So framing a wrong questionnaire is also a reason for non-sampling error. The next idea, I may apply a wrong measure for finding mean or standard deviation, or for finding correlation. I may do something else. So that is also a reason for it. The next, incomplete investigation. The investigation itself is not completed in a proper way, or the sample survey is not complete. That also leads to non-sampling errors. So errors, we have two types, sampling error, non-sampling error. This is actually chance error, and this arises due to human factors, and we have seen what all leads to them. Sampling distribution. How do you define sampling distribution? Let me say, there are 50 persons again, that is the population. I am selecting a sample of 10 units. There are 50 persons. I am selecting a sample of 10. How many samples can I select? 50 are there. I want 10. So it is 50 C10 combination. From 50, I want 10. So how do you write it? 50 C10. So that many samples are available. Each sample, you calculate mean. So X bar for the first sample, X bar for the second. So mean of every sample I collect, tabulate it. The frequency distribution of the various values for sample 1, sample 2, sample 3 like that. The frequency distribution I form using all the mean values or using all the standard deviation values. So this is called sampling distribution. So sampling distribution, just to say in few words, frequency distribution with various values of a statistic. What do you mean by the word statistic? Sample constants. It can be mean or standard deviation or any sample constant that we calculate is called statistic. For this statistic, I create a frequency distribution, the values from all the samples, all possible samples. That is called sampling distribution. Once I know the sampling distribution, find the standard deviation of it. The standard deviation of the sampling distribution of a statistic we call standard error. This is a very important term in the subsequent exercises to do. So what is standard error? Standard deviation of the sampling distribution of the statistic. Find the standard deviation of the sampling distribution that we call standard error. Some of the values we have written. Suppose I am calculating sampling distribution of mean. X bar we denote. What is the standard error of sample mean? We say sigma by root n. Sigma, standard deviation of the population. Root n, n is the sample size. So sigma by root n, a very important formula which we use in the subsequent exercises. Not only for sample mean, I can also find standard error of sample proportion. Sample proportion we call small p, and standard error we have defined root of pq by n. Capital P and capital Q, the proportion values of the population. One if I take as success, the other one is failure. So root of PQ by N. For standard deviation, we have the formula root of sigma squared by 2n. So standard error constitutes a very important place in hypothesis testing as well as in confidence intervals, which will be dealt in detail in the next exercise.